let me introduce our last but not the least speaker, and I can kind of relate to him while I'm double of his age right now. But I remember when I was young, I used to build my own toys. I used to go out, see in the market what the toys are. If I couldn't afford to own them, so I'll go back at home and build my own toys. I didn't have the Raspberry Pi at the time. I did a lot of tools which he has now, which helps him to do a lot more things. So our next speaker is Saral Tayal. He is a 19-year-old maker. He is one of the. He is going to talk about how IoT will enable the makers community. Because as we seeing the professionals out there in a suit and tie, I think the next generation is going to change even differently. So generation like him is going to bring a lot more insight, a lot more new thinking, how we should use the IoT. And when I was talking to him, I told him that you have to show us something working. And when I was looking at his website, he has almost like 200,000 views on some of his videos, and he has won Amazing Voice Challenge, Grand Challenge, his Global Challenge. Let him explain more what he does, and floor is yours, sir. Welcome him.
Thanks.
Round of applause, please.
Thank you. So I'll be talking about growing IoT in the DIY and maker community because this conference is primarily focused on IoT, but it's all on the commercial side, right? Like all these big corporations. But like CP mentioned, the next generation will be all youngsters, and it's not just the professionals who do it, it's not just the computer scientists, but anyone can participate in IoT, and I'll be talking about that. So I'm 19 years old, I've been in the maker community since 13. That's another picture of me at Maker's Block. It's like a Maker's Fair, if you have heard of that. So that was one of my first Maker Fair, and I'll be studying at Carnegie Mellon next year. I'll be studying robotics, so I'm enrolled in that. And here are the places I've worked with. So my first internship was with XPC, which is by HomeFix, and what I did over there was I helped design their electronics fabrication lab. Then I've presented at the Autodesk headquarters some of my projects that I've built, and I'll come to in a second. I held workshops, and I talked in Maker's Block, and I helped spread the Makers movement. Then I publish a lot of my projects on Instructables, and I've been in touch with them, showcasing my projects both online and in person. Then I've worked with QuickFab, that's a 3D printing startup in Singapore that builds 3D printers for NUS, Polytechnics, architects, HR. They build really custom, high-end 3D printers. And then again, I've been involved in Maker Fair Singapore. And in fact, as of today, I'll be published. One of my projects that I'll showcase you will be published in Hackspace magazine. So if any of you have heard of Raspberry Pi, it's their own magazine. Like the Raspberry Pi creators have created a magazine called Hackspace, and I'll be publishing it here today. So this is my Instructables blog. Not all my projects are here, but some of my projects are here. Such as I developed an electric longboard that I've prototyped out of 3D printed parts to make it really easy for anyone to build. I built my own 3D printer, and here, this was my first project, RC thrust vectoring hovercraft. So unlike traditional hovercrafts that have rudders, the whole back-mounted fan would move left to right to control the hovercraft. So this was published, as you can see, in 2014. That's when I started publishing my projects, and that was 4 years ago when I was 15 years old. Then this is another one. This is a home automation system. So I don't have a video of it here, but I'll give you a link to my Instructable that has this video. But basically, you touch this little pad on the door, and then your whole door would automatically open based on this motorized system that I've developed. And you could track, how often people have come in, what times do you open the door, what times you close the door. So this is, going into IoT where you have user data has to use how people use. Then this is a 3D printer that I built when I was in 10th grade. This is one of my best projects. It's a longboard I was talking about. So as you can see, the little components at the back are all 3D printed. So the mounting for the electric motor, the mounting for the for the electronics, everything is 3D printed, the longboard is cut by hand. And yeah, I mean, these are just some of my projects that I've built. And this is the one I really want to talk about. It's a floating smart mirror. Basically, I'll get to it a bit more later, but let me talk about IoT first. So the smart mirror won the grand prize for Amazon's Global Voice Activated Challenge as well. Anyway, so I want to talk about hands-on learning. It's commonly understood that there are 3 types of learning. There's the learning that you derive from laws. So, you know, it's like physics-based learning. Then there's a second learning, which is, you know, vocal learning, if someone tells you something. And the third type of learning is experiential learning. So I'll give you an example with fire. You know, you could take like an infrared thermometer, see the temperature of fire and be like, okay, that's going to burn me, you know? So that's the first type of learning. It's the kind of learning where you see the laws, you see, okay, that's a really hot temperature. If I touch it, I'll be burned. The second type of learning is, you know, handed down to you. Your parents might tell you as a little kid, don't touch the flame, that'll burn you. You know, that's the second type of learning. The third type of learning is actually touching the flame and realizing that it burns you. You know, it's experiential learning. And quite arguably, experiential learning is the most important learning. In fact, Aristotle said, I think in 350 BC, that you cannot do anything without experiential learning. And hands-on learning is the best way to learn. So, I mean, in the maker community, in the IoT community, if you want to bring people in, you have to have people take around. You want them to make projects. You want them to, you know, express themselves creatively. You can't just teach them bookish knowledge. You can't just tell them, okay, you do this, you got, you know, program this and that. They actually have to do it. So in today's society, the maker community directly goes against consumerism, because consumerism nowadays, especially with all these big companies, that you buy something and use it for a few years, it breaks or it's designed to fail or designed to be obsolete, so you buy something else. So a good example is smartphones. Before, phones used to be really easy to repair, or even electronics appliances. You know, if you've ever seen repair shops have gone down. I mean, how many repair shops do you see nowadays? You break a laptop, anything in the laptop fails, you go get it replaced. You don't get it fixed. But before, people would get it fixed. You know, things are not as modular. They're not made to be tinkered around with. And the maker community is all about, you know, targeting that and combating that. In fact. So in Singapore recently, in the past 4 years, has promoted the maker movement. So like, here are a few of the local maker-friendly venues, like, you know, Maker Space at XPC, like I talked about, the Maker Fairs, Science Center is doing some good work, National Design Center, One Maker Group, Sustainability Living Lab. But these have only picked up in the last few years as the maker movement spreads. And IoT predictions, I mean, there are many predictions, but some of them go from 20 billion to 50 billion. And IoT is very important because IoT is all about data and harnessing data in important ways. Although it's about connecting devices, it's also about understanding people's behaviors. And the best way to do that is to empower to make. You have to make something physically to understand any sort of technology, and understanding, being able to work with IoT especially means that you can work with a lot of technologies. You're getting experience with software design, coding. You're getting experience with sensors, physical hardware, and building everything. So it's a very holistic approach to making. And yeah, I mean, I'll talk about my smart mirror, which is a great IoT project that I just built. It's built off this. As you can see, it's built off this one-way mirror. I mean, if you've ever seen any movies, you know, in police stations they'll have these one-way mirrors, and then there'll be someone behind, and inside the actual cell or something, where they're interrogating someone, they'll be talking, and it looks like a mirror, but behind the mirror there's someone. That's the exact same technology I've used. I've just put an LCD display behind the mirror. Yeah, so it's a pane of glass with a one-way mirror film. It's very cheap, in fact, it's just a couple of dollars. And with what you do is you take any traditional LCD monitor, like here's an LCD monitor assembled in the left side image, and you put that behind it. Basically what it does is, if the LCD monitor is off or displaying black, any sort of light that goes on it is reflected. So you can see a reflection very clearly. And I'll show you a few videos where you can see this clearly. But anything from behind, if it's color, will pass through. So it gives like an illusion of a smart mirror. So yeah, I mean, this is a build that I've done. It's just a proof of concept, but basically how it works is you can interact with it via a touchpad. There's a motion controller as well, so you can use your hand gestures. Although it's a little, it's not that sensitive and it's not that accurate. And then lastly, what I did was I integrated Amazon Alexa. I mean, Amazon Alexa and the Echo ecosystem is growing, so I got one of these Echo Dots. These little circular smart speakers connected to Amazon Alexa, and I just hit that behind. So basically, you could give it a voice command and it would give you any sort of answer. You know, like play your favorite music, voice control. So like in that sense, it's instantly open to a huge ecosystem. So I mean, I have a few demo photos and videos. So as you can see, it's a demo photo. It looks like a mirror, you know, but I have all these applets, and I mean, yeah, there's a video as well. Just like you play the video, please? Thank you. Okay, so here's my smart mirror. As you can see, there's a calendar, there's a quote, there's a random fact, and there's some news, and you can browse this. And then there's a clock here, an analog and a digital clock with, you know, a fancy readout. So I mean, if you want to browse, there's a trackpad here, so you can say on the news, you can go to the business tabs, the sports tab, entertainment tab, and you know, you can read what there is. Or you can say, you know, for instance, browse YouTube. So I'll open up the YouTube applet and it'll open up a browser over here. And so if, I don't know, I'll just play some random video so you can see. It's muted, so I'll just turn up the volume. So you can watch videos, or perhaps if you wanna, you know, check your Facebook, you can open Facebook. Here, once again. Check Facebook. So just launch the desktop, you know, version of Facebook. I haven't logged in yet.
Yeah, so I don't have too many apps right now, but basically, as you can see, there are a lot of widgets. So there's a calendar widget, a random code, a daily fact, there's a search, and other widgets. And this is very customizable because it's running on Windows. Basically, what I did is I had an old laptop and I tore it down. I mean, in the photos you can see, yeah. So there's a laptop motherboard in there. It's sort of hard to see. It's on the top right corner. But yeah, there's a laptop motherboard basically that I've disassembled, and doing so makes it sustainable because you're not necessarily buying new components and you're just using old components. And old laptops, you'd be surprised, are actually quite capable, and running something as simple as this is very easy for old laptops to do. Plus they have, you know, storage devices, they have Wi-Fi and everything built in. And in fact, you can also use a laptop display behind the mirror, but I've used like, you know, a second-hand old computer monitor. Anyway, so here's another short video. This one, thank you.
Okay, so here I'll show you the Spotify integration. I have Spotify open, it's zoomed in so I can show you the specific part. If I play any song, a really nice thing is on the mirror, you'll get the artist name and you'll get the track name. It's just, yeah, up there in the corner.
So again, just another example of the Spotify integration. So one good thing is anywhere you're in the house, right? You could play music, and from your smart mirror, you can control the music. And again, there are many apps. There's Reddit, there's Skype, so you can do video calls. There's a small little webcam behind the mirror, so you don't see the webcam, but the webcam can see you because of the one-way mirror. Then yeah, here's the last one. This is a demo of.
Okay, so I'll give you a demo of the motion control system. You can use your right hand to control the mouse, and you can use your left hand to control the scrolling and the clicking. So if I come in here, this is the Reddit page for instance. I'll bring my left hand in, and based on how much I angle my hand, as you can see, I'm scrolling around, and then I can bring my right hand in and control the mouse. Maybe it's a little hard to see, so I'll zoom in for you. Maybe now you can see. I'm moving the mouse cursor around based on the movement of my hand. Anyway, so if I want to click on a link, I'll bring both hands in, I'll go in and I'll close the mouse, little fidgety. There, so I've clicked it, and now it'll load up the page.
So again, but the technology I'm using is something called Leap Motion. I don't know if you guys have heard of it, but it came out a few years ago, and it's this little $70-80 device that's used for VR hand tracking. So I mean, I was experimenting with motion control because say you want to use this in an environment where you don't want to use a trackpad, maybe you're brushing your teeth or something, and you want to use your spare hand to quickly control something, or use gestures to turn the volume up, turn the volume down. I mean, the gestures are infinitely customizable. It can go down to single finger tap, or you making a fist, or you angling like I showed you to scroll, or flipping your palms up. I mean, you can do a lot with gesture control. So I mean, this is an example of an IoT mirror because you can make any sort of widget to track what you want to do. It has voice recognition, so you can ask it any sort of question, so you don't even have to be close to it. You can be far away and shoot it a question, and stuff like this. So there are a lot of DIY IoT solutions that are out there: Intel Edison, Blink, Arduino, Raspberry Pi, and so on. And then there are a lot of resources as well, like there's Adafruit, there's Instructables. I mean, this is just me searching IoT on Instructables, and you can see there's so many projects. IO, and then there are tons available. And then I've also started a company called Thinkerspark because I've been working with Maker Faire and Maker Block for so long that I have a lot of experience with teaching and building these projects, and even with Instructables, posting resources for how to build your own projects. So with Thinkerspark, I'm doing that as well, but I'm doing it to the audience directly. So I'm hosting classes for little kids in like circuits and electronics, programming and robotics, soldering, drone building, 3D printing, and even an IoT weather station. Because it's actually incredibly easy to build a simple weather station and a simple app on your phone. Track it wirelessly. So yeah, this is our story. Just Thinkerspark. That's what we do. And here are some sample workshops: programming, robotics, soldering. These are some that we've done so far, and we're going to do some more later. So yeah, question and answers.
First of all, round of applause to Saral. Any questions for him? If no question, let's wish him all the best for his degree next year for Carnegie Mellon. And I'm sure he's going to do a lot more better things in the situations like that. Second thing is just to make a comment, like while we can think a lot of new ideas with the thing, but actually what I like more is reusability of so much of trash we are throwing out there. Like I said, that we actually just throw out when we don't use. This is the mindset right now we have. But actually, so much of hardware, software, we can reuse to build a lot of other things like this. So with that, I'd like to thank again for Saral, and I hope we do much more wonders.